Hello, I'm Terry Hunter.
And I'm Gemma Hanlon, and for the next 5 minutes or so we'll be showing you the utilities for troubleshooting a network as Network Administrators.
Before we begin telling you the problems that can occur in a network, we should tell you that networks have many benefits too. When they are running smoothly, networks provide an efficient method of sharing. It allows users to share information like files and emails, resources like printers, disk space and internet connection, as well as sharing applications. A design department using AutoCAD, for example.
For networks to communicate efficiently, they need a set of ground rules. These are known as protocols. Networks on the internet use a standard protocol called the TCP/IP suite, which covers the Transmission Control Protocol and the Internet Protocol.
TCP/IP is made clearer in the OSI reference model, which stands for Open Systems Interconnection. When a data packet is sent over a network, it passes through 7 layers to reach its intended destination. Here is a summary of what happens to the data as it progresses through the levels, starting from the bottom. Layer 1, the physical layer, deals with the layout of the network, focuses on the cables, devices and connection signal. Packets are viewed in binary code at this layer. Internet protocols govern this layer, setting a standard for the network hardware.
Layer 2, the data link layer. The packet is directed over the network using a MAC address, a physical address assigned to the device by its manufacturer. This layer listens to traffic to avoid a collision of packets being sent over the network at the same time. The layer also uses the Ethernet protocol.
Layer 3, the network layer. Here IP protocol passes the packet from the MAC address to the IP address, a user-defined address that gives an indication of the network a device belongs to. IP addresses are invaluable when troubleshooting networks. We will be showing you some of these shortly. Layer 4, the transport layer, whose purpose is to get the packet to its destination. It does this in one of 2 ways. The first using TCP protocol, which ensures a reliable delivery and receipt of the data, and the second using UDP, which doesn't have the same efficiency and requires the user to manually request that the information be sent again. Layer 5, the session layer, establishes connection-based transmissions between network devices, referred to as sessions and managed by the session layer protocol. Layer 6, the presentation layer. The data in the packet now needs to be converted, as different systems will use different formatting techniques to exchange information. Layer 7, the application layer. The last stage communicates the data with the relevant application program to request network services.
The IP config tool shows the computer's TCP/IP configuration. It displays the IP address, the network subnet mask, the values and the internet network gateway addresses. Use this tool to verify that TCP/IP configuration has been set up correctly. It also refreshes the dynamic host configuration protocol as known in DHCP. To use ipconfig, go to the Run in the Start main menu on your desktop. Enter in Run, CMD, and once again the command prompt will appear with a black interface. Enter ipconfig. Now that you have entered this, you will see configuration information, including the IP address, the subnet mask, and the default gateway. Ping is a very useful troubleshooting tool for networking computers. The Ping tool can show that TCP/IP is installed correctly on a computer and that a computer has joined the network successfully. It also ensures that a computer can reach the internet, that a remote website or computers is responding, and that a computer name revolution is working. Ping can be used to test connectivity and response time. To use Ping, enter Ping 127.0.0.1, the loopback address, to test whether TCP/IP is installed on your computer with information on packets sent below. If the loopback test was successful, you are now ready to ping another host on your network. To ping another host computer, enter in the command prompt ping and the other host IP address. Again, like with the loopbacking test below, should be information on the connectivity with the host, showing the response time and how many bytes of data were used to ping. This now shows that the computer is on the network. The host name utility displays the computer's host/domain name. This tool is often used on a computer to identify its name when attempts to map network drives on that computer fail.
The fourth troubleshooting tool to know about is traceroute. Traceroute is a more advanced version of ping and likewise uses the same syntax, entering the command name followed by the destination computer you want to troubleshoot. It gives details of each router that the packet passes through to reach its destination. Each router is called a hop and counts up to a maximum of 30 hops. So let me show you an example. To trace the route between my computer and the Northampton University website, I type in tracer space www.northampton.ac.uk. This will immediately bring up the destination's IP address, which is an alternative way of navigating to a web page. So after a little searching, the results show that the Northampton University website is 3 hops from my current network location, as well as the IP address of each router, the time taken at each hop, my default gateway, and the default gateway of the target destination. The default gateway is a device that joins one network to another. To find the full list of alternative switches for the traceroute command, type in tracer space /?. This includes options such as limiting the number of hops displayed or listing the hops with only the IP address information shown. Tracer is a useful tool when troubleshooting a network. From the response details given, we can see where a problem occurs between 2 hosts, as well as the time taken at each router indicating any issues with connection speed. Fifth of the main troubleshooting tools to know is ARP. ARP stands for Advanced Resolution Protocol, which maps the computer's IP address to its corresponding MAC address. Information is requested from the data link layer and the network layer to produce the ARP table. Typing ARP into the command prompt brings up a list of the command switches. We'll go through a few of the more popular ones you may need. ARP-A shows you all of the MAC addresses that your computer knows about on the network, with a listing of the corresponding IP address. There are 2 types of ARP entry, static and dynamic. Static entries are manually created links between the MAC address and the IP addresses, whereas dynamic entries are assigned automatically. ARP-S, followed by the computer IP address and MAC address, allows you to add a static entry. ARP-D deletes entries from the ARP cache. If a computer on the network is having problems, yet the ping response is successful, use ARP to check the IP address has not been assigned to 2 MAC addresses by mistake. You can also use ARP to restrict access to a network by only allowing connections to devices that have been added to the ARP cache. Route is our 6th troubleshooting tool. This tool shows us how routers direct packets around the network. Routers determine where a packet has come from or where it is going to, forwarding the message to the destination network segment using a routing table. Routers are a network layer device. Typing route print into the command line brings up the routing table. This shows you the network destination with the router's linked IP addresses, the net mask, giving the subnet mask of the network segment, the gateway, this is the IP address that the packet should be forwarded to, the interface, telling us the network interface card that is connected to the appropriate destination, and the metric, which finds the best route to that destination. Each time a packet is sent over a network, the router refers to the routing table to determine whether it should listen to the packet or forward it to the destination host. To see the full list of route commands, type route into the command line. It just depends what problem you've discovered. The 7th and final tool we're going to show you is NetStat. This tool shows the active TCP/IP connections and is used to troubleshoot applications. So let me show the output format. Type NetStat into the command line to see the protocol that is being used to pass data around the network, the address the computer is using to make a connection, the foreign address that I am receiving data from, and the state of the connection. To check the basic Ethernet setup, type netstat-e into the command line. This shows the network statistics and verifies that I am able to send and receive data on the network. Typing netstat space / into the command line gives you the list of command switches.
We hope this has been useful to show you how you can troubleshoot a network with just a few simple tools. Thanks for watching.